Good evening. Today is our first class as per our announcement. But I have given instructions the last class on Saturday. I would expect the students to go through that introduction so that it will certainly help you, because I have given some tips and suggestions for effective answering of the KCET. Today, we shall discuss about set theory, relations, and functions. See, the entire chapter here, it is first PUC as well as second PUC. So the relations and function, I have combined both first PUC and second PUC portion. I'll be discussing about it. Now, what are the things you need to know before we start the actual problems of CET? I'll just list out those things. In set theory, what is called roster method. I'm just listing them. Tabulation method, roster method, tabulation method. Then these are same. The next is rule method. Now, all these things you have studied, I'm just helping you to recollect this. Now, next we have to discuss about types of sets. What are those? First is empty set. Singleton set. Then finite set and infinite set. These are all very familiar things for you, but still I am listing them. Then we have what is called subset, equal set, power set, just all these things are familiar to you. I'll just talk about power set. Power set is denoted by P of A. It is the set consisting of all the subsets of A. Now here, it is better we call the formula for number of subsets of a given set. Is equal to the power of n. You are familiar with this formula, but I am just discussing, where n is the number of elements in the set. We have got what is called powers, this proper and improper subset. What is proper subset and what is improper subset? proper and improper subsets. Just remember the set A and the null set, they are called improper subsets. And all other subsets are called proper subsets. Next, just listing out so that you can, if you are not familiar with these words, kindly go through that, because in the given time I will not be able to give the definition of all of them, only just listing out. The next is what is called universal set. Denoted by U. In fact, must also discuss about Venn diagram. What is Venn diagram? It's a method suggested by a mathematician, John Venn. John Venn suggested that we can represent the universal set by a rectangle and sets by circles. Supposing we write like this, these two are called joint sets, and if I write like this, these two are called disjoint sets. Can also recall what is A minus B, what is B minus A, all these definitions, kindly go through that. Then we have operations on set. One is union of two sets. Next is intersection of two sets. If two sets intersection is a null set, then those two sets are called disjoint sets. Then I'm just listing out different subset A minus B we discuss. What are the questions that has appeared in the examination in the KCET paper which I'll discuss? So we are going to discuss the questions which have appeared in the KCET examination. And those questions you'll be able to understand if you have gone through whatever I have listed. Okay. One of the questions they have asked is the set A equals X such that modulus of 2x plus 3 is less than 7 is equal to the set. Is equal to the set. See, in the last class I have told you I will not be listing all the four options given. You'll only work it out, then you can just pick the right answer. So you have to find out what are the elements of this set. How do you find out the elements of this set? So what is given? It is given that 2x plus 3 modulus is less than 7. What does it mean? Minus 7 is less than 2x plus 3, that is less than plus 7. So you should know how to solve the linear inequality which you have studied. So how to first, what you can do is, you can add plus 7 to both sides. Minus 7 plus 7. No, we shall, instead of plus 7, we'll try to remove this 3 first. So we'll add 3 to both sides. Minus 7 plus 3, 2x plus 7 plus 3. The linear inequality, what you have studied in first year PC, we are discussing. So this will give you minus 4 less than 2x less than 10. Now you want only x, therefore divide by 2. Minus 2 less than x less than 5. So what are the elements? It is greater than minus 2. So you can write this as Greater than means minus 2 is not included, and 5 is also not included this set. So this set consisting of the elements between minus 2 and 5. Now, what is the knowledge that you need to work this problem is you should know how to solve linear inequality problem. The next problem they have given is write I'm just working out the problems which are given in the examination paper. Write the set builder. Write the set builder. Set builder form of A is equal to minus 1 comma 1. See here, you can write in different ways. What are the different ways? Set consisting of the elements minus A and plus A. The set consisting of the elements minus A and plus A. I'm sorry, minus 1 and plus 1. Both are included. Or in this particular examination, they have asked a question. Set solve the equation x square minus 1, solution of this equation. So you are going to look at the answers given. Here I want to list all the answers, but this is the most relevant answer because solution of this x square is equal to 1 is nothing but minus 1 and plus 1. So some questions are given like that. The other question you find is what is n of A? This knowledge you should have. N of A means number of elements of A. So normally there are some questions given the examination based on this N of A and all that in the public examination. We shall solve them. One question asked is if N of A is equal to 2 and the total number of relations I've asked. So before I go for this particular problem, I will also have to discuss about let me discuss about relations and functions, then we'll come to this problem because we need a knowledge of, because the question was this, how many relations can be defined. So let me first discuss relations and then come to this question. So we have only discussed about the set theory. So what are the possible questions that can be asked in set theory? They will give you some sets. There was a question one of the year, which of the following set is an empty set? The answer for that was x square plus 1 equal to 0. X belongs to real number. See, of all the answers, this was the best answer, rather suitable answer. Why this is suitable? If x square plus 1 is equal to 0, then x square is equal to minus 1. This doesn't have a solution in real number. What solution of this is a complex number. Therefore, when they ask an empty set, you have to search for solution. What I'm trying to tell you is, here I'm only discussing the questions and all the 4 answers, it takes a lot of time. I just want to give you an idea how to work these problems. So there can be a question on empty set. There can be a question of given 2 definitions and they say which of the 2 are equal sets. What is you know what is an equal set is? Two sets are said to be equal if every element of one set is same as the, or every element of both the sets are same, or the elements of both the sets are one and the same, or one is a replica of the other. So we'll just first give you some idea about what a relation is. Relations. And we have found that not many questions are asked in set theory in the public exam, that is CET examination. Public examination different. And every year they have not asked, only few years. And normally questions are based on the definition of set or set builder, or maybe on subsets also. So if you have a clear idea of these kinds of sets, then definitely you will not have any problem answering set theory. So we'll just move on to relation. So before we go for relation, you should have an idea of what is called Cartesian product. Let me once again make it clear to you that in these classes that I am conducting on CET, I am giving more importance to the concept than the problems. Because the problems have 4 choices. Writing all the 4 choices will take a lot of time. And we will not be having a common question paper also. So what I am trying to do is I'll give you the clear idea about the concepts. Once the concepts are clear to you, then working these problems becomes very easy. So Cartesian product, it is defined as A cross B. What is a Cartesian product? Set of all order pairs A comma B, where A belongs to A and B belongs to B. Set of all ordered pairs A comma B, where A belongs to A and B belongs to B. This is called A cross B Cartesian product. And if A has got m elements, A has m elements, and B has n elements, then A cross B will have mn elements. The question is how many subsets we can define, that is A cross B will have 2 to the power of mn subsets. So I'll just discuss about this. A has m elements, B has n elements. A cross B will have mn elements. And A cross B will have 2 to the power of mn. You can just say, instead of elements, subsets. Now, what is a relation? A relation from the set A to the set B is a subset of A cross B. A subset of A cross B is called a relation. Now the question is, if A has m elements and B has n elements, A cross B will have 2 to the power of mn subsets. That means we can define 2 to the power of mn relations from A to B. In this case, we can define 2 to the power of mn relations. Here, the relation corresponding to phi and A cross B. This A cross B is called universal relation, and this is called a void relation. That's the word used. So there can be a question in the examination, how many relations we can define and what is a void relation. The examiner can frame the questions involving these concepts. So if you have a clear idea how many elements A cross B will have, how many subsets A cross B will have, each of the subset is a relation. Let me just take a very simple example to make this point clear. I'll take a very simple example. Let A is equal to 1, 2, 3. B is equal to A comma B. So how many, if you find A cross B, what are the elements? 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, 3 comma B. A has got 3 elements, B has got 2 elements, A cross B has 6 elements. 1, 2, 3, 4, 5, 6. Supposing I take a subset of this. If I take a set, say P is equal to only 1 comma A and 3 comma B. I take only this. This also relation. Every subset of A cross B is a relation. So as we listed here, it will have 2 to the power of 6 subsets. And you can define 2 to the power of 6 relations from A to B. Of this, the relation connecting to A cross B, and what is a null set? See, when I say that it has got subset, null set is also a subset. Null set is called improper subset, and A cross B is also called improper subset. So there can be a question in the examination. Number of proper subsets. In this case, it is 2 to the power of 6 minus 2. Because there are 2 to the power of 6 subsets, you have to subtract 2. The set corresponding to A cross B, the set corresponding to 5, you have to subtract this. So if you have an idea how many subsets are there, what is A cross B, what is a proper subset and improper subset, the questions framed on this can be worked out. Now, the question that was asked here in the examination was, if n of A is equal to 2 and total number of relations from set A to set B is 1024. Then find n of B. See here, I would like to spend little more time because we will not be able to work all the problems. But when you work a problem, we should be able to get a clear idea about the problem so that you can, any problem this type, you can work. See, n of A is 2, n of B is not given. So you have to find n of B. How to find n of B? Let us say, let n of B is equal to x, or let us use P. Because the moment we use x, it becomes an algebraic equation. I'll use P. So if A has got 2 elements and B has got P elements, number of elements in A cross B will be 2 to the power of 2p. Try to understand this. If A has got m elements, B has got n elements, A cross B will have 2 to the power of n. Sorry. We'll have 2p elements. Sorry. A cross B will have 2p elements. So number of subsets, please make a action. A cross B will have 2p elements because if A has got n elements and B has got n elements, A cross B will have mn elements. I have taken this as p, so A cross B will have 2 to the power 2p elements. Number of subsets of A cross B will be 2 to the power of 2p. What's the reason? Number of subsets is equal to 2 to the power of n, where n is the number of elements. This has got 2p elements. So what is given in the problem? N of A is 2. Total number of relations from set A to B is 1024. Therefore, it is given that 2 to the power of 2p is 1024. Now you have to use the formula a to the power of m is equal to a to the power of n implies m is equal to n. So you have to convert this 1024 as a power of 2. See, all of us know 2 to the power of 5 is 32. Start calculating. 2 to the power of 6 is going to be 64. 2 to the power of 7 is going to be 128. So what is 2 to the power of 8? 2 to the power of 5 is, this is 256. 2 to the power of 9 is 512. So 2 to the power of 10 is 1020. So here, if you can realize 32 square is 1024. 2 to the power of 5 to the power of 2 is 32 square is 1024. The problem is going to be easy. Otherwise, you are going to spend some time. This is what I talked about in the introductory class, a known difficult problem. Not very difficult. Some skill you have got to use. So you get 2 to the power of 10. Therefore, p is equal to 5. Therefore, n of b will be equal to 5. They would have given the 4 answer, n of p is 4, 6, something like that. You have got to take the right answer. What is the other question they have asked? There's a question on relation in one of the examination paper. The question is, let the relation R is defined by A or B. That's common notation used. A is related to B. If 3A plus 2B is equal to 27. Then what is R? They have asked. Find R. So what happens in this problem is, they have given some answers. Say for example, they might have given the first answer as, just write one only first answer, 1, 2, 3, 9, 5, 6, 7, 3. So there is no other method for this problem. We're going to substitute. If you put A is equal to 1 and B is equal to 4, 4 plus 3 is 7. Now this is 3 plus 4. So it's not 1 comma 2, it is 1 comma 12. Otherwise it will not satisfy. 1 comma 12. So if put A is equal to 1, 3, 12 to the 24, 27 is satisfied. So what you can do is, there would give one more answer. 1 comma 12. I'll write all the 4 answers for this problem just to give you some idea. 3 comma 9, 5 comma 6, 7 comma 3, 9 comma 0. I'll just write all the answers so that I can give you elimination method for this. 0 comma 27 by 2, 1 comma 12, then 3 comma 9, then 5 comma 6, 7 comma 3. The answer B is 2 comma 1, 9 comma 3, 6 comma 5, 3 comma 7. So just observe 1 comma 12 is present here also, here also, here also. But here 9 comma 0 is extra number is there. Here 0 comma 27 is there. And here 9 comma 3 or 6 comma 5 is there. So what you can do is just substitute 9 comma 0. What happens if you say substitute 9 comma 0? So it will be 27 plus 0, 27 you will get it. So that is not possible. Then you have to find out one number which is not present here. 1 comma 12, 3 comma 9 is there, 5 comma 6, 7 comma 3. And here, in case if you substitute 0, here 0 and 27 by 2, you are not getting 27, therefore this is not the answer. And if you substitute 9, 9 3 itself is 27, this cannot be the answer. See, you can't substitute everything, you have to just observe it. So here most of the terms are same, therefore let us rule out which is not possible. This is not possible, this is not possible. Between these two, you have got to decide. So 1 comma 12, this is same, 5 comma 6 is same, 7 comma 3 is same, 9 comma 0, both answers are possible. There will be some mistake, I think. So this is the correct answer. But what has happened in this case, if 9 comma 0, everything is possible. 7 comma 3 is also possible because it is 21 plus 26. 5 comma 6 is also possible. 5 comma 6 is 15 plus 12 is 27. 3 comma 9 is possible. 9 plus 18 that is 27. 1 comma 12 is also possible. So you are getting 2 answers correct. So there may be some mistake. Maybe you might copying a method as a mistake to decide. So I'll not work one more problem this side, but I am suggesting you what is the elimination method. When you observe, you notice most of the elements are same, but you find a peculiar element here. You can substitute and see that is not the answer. Therefore, this is ruled out. Now you can see 9 comma 3. The moment you put a equals 9, it is more than, so this is also not possible. Between these two, you have got to decide. Now you could have chosen the number, say for example, no need of checking this. So you have got to check only this. Unfortunately, that was also correct answer. Perhaps there was a mistake. Suppose if such printing mistakes are there, they will give any one of the answer you write, you will get marks. Normally, such mistakes will not be there. Maybe there was some mistake that I don't remember because I have copied it like that. There is another question. The number of suppose the number of elements in set A is P. is P, and the number of elements in set B, and the number of elements in set B is Q, and the number of elements and the number of elements in A cross B is 7, then find P square plus Q square. They would have given 4 answers. You have got to take the right answer. So what is the concept required for this? Set A has got P elements and B has got Q elements. Therefore, A cross B will have 7 elements. That is PQ elements according to definition. Therefore, PQ should be equal to 7. Now 7 is a prime number. Therefore, what are the possibilities? P is equal to 1 or Q is equal to 7, or P is equal to 7 or Q is equal to 1. Whatever it is, P square plus Q square is going to be 49 plus 1, that is equal to. Supposing instead of giving 7, if they give any other number, supposing they give PQ is equal to 15, then what will happen? There are many possibilities. 5 into 3 can be 15. 15 into 1 is 15. So you have got number of possibilities will be there. Therefore, they will always give a prime number. In case if they give any other number, they have got to give more choices. Either P is equal to 3 and Q is equal to P is equal to 5 and Q is equal to 3, or P is equal to 15 and Q is equal to 1. All possible answers will be given, sir. But what is the concept required here is to remember A cross B will have mn elements. There's one more similar problem of the same type which I have listed here. Yeah, I think such sets of problems we can work it out. Let us not waste more time on that. That will take lot of time. It will. Okay. So we'll just work out some problems on relations which has been asked in the examination. There's one problem. If f of x, I'll work out some problems of relation during the examination period. F of x equals 2x square. Then find f of 3.8 minus f of 4 divided by 3.8 minus 4. That's a very peculiar problem, and in fact, if you start working directly, supposing you try to start finding what is f of 3.8, it is going to be 2 into 3.8 a square. Lot of time is consumed. But these are the problems with the examiner's frame in such a way that you can use some skill. I was talking about skill in the last class, in introduction. Here some skill you can use. So let us say 3.8 I call it as A and 4 I call it as B. So what is f of a? F of a is going to be 2a square. What is f of b? F of b will be 2b square. So what do you get here? 2 we can take common. You get 2 into a square minus b square. This is a minus b. If you cancel, you get a plus b. So you got to add 3.8 and 4. That is 7.8. You have to multiply this. 7 to the 14 plus 1.6. 15.6 is the answer. I repeat. Yesterday in the introduction class, Saturday in the introduction class, I was talking about a problem involving skill. This is a problem. If you don't use this and if you start substituting f of 3.8, a lot of time is wasted. So this is what you find in CET. Some of the problems are given in such a way that which can be solved using skills. How to learn that? For that you should learn previous year's paper. Okay. There is another problem of the similar type in the examination. Let f from R to R defined by f of x is equal to 2x such that x greater than the x squared 1 less than x less than 3 and 3x x less than or equal to 1. So while giving you hints and suggestions, I was talking about first round and second round. This problem should not be worked in first round, because if you start working this problem in first round, you'll be wasting a lot of time. So what you can do is, you can go for this problem second round. What is that I have asked you to find? Problem is not difficult, but it takes time consuming. F of minus 1 plus f of 2 plus f of 4. Here you have to be very cautious. To find f of minus 1, which one you should use? So here, this is greater than 1. This is greater than 3. Therefore, you have got to use this. F of minus, because less than or equal to 1. So minus 1 is less than 1. You can use this. Therefore, you get f of minus 1 is minus 3. Next, what is the question asked? You are asked to find f of 2. For f of 2, you can choose this, because 2 lies between this. That is going to be 4. F of 4 is greater than this. You get 8. The answer is going to be 9. Not a difficult one, but you have got to spend time. You should not be in a hurry. You have got to decide which one you have got to use. For this, you have got to use this. Next year, what they have done is, they have kept these problems same, but there was something different. F of 3, something like that. F of minus 2, something like that. So therefore, if you take little more time, as I said, keep yourself cool and decide. It is not a difficult problem, but you've got to work this problem in second round. So this is another type of question you get in relations, and there is one more question. If f of x equals ax plus b, where a and b are integers, f of minus 1 f of minus 1 is 5, is minus 5. F of minus 1 is minus 5. And f of 3 is 3. Then find a and b. Not a difficult problem. You got to analyze what is f of minus 1. F of minus 1 is equal to, you are putting in place of x minus 1, you get minus a plus b. That is given to be minus 5. What is f of 3 you calculate? That is 3a plus b. That is equal to 3. This is a simultaneous equation problem. You subtract minus 4a is equal to minus 8. Therefore, a is equal to 2. So, what is b? B is equal to 5 plus a. 5 plus a is 2. So, b is equal to 7. I'm sorry. Minus 5 plus a. Minus 5 plus a. Therefore, minus 5 plus 2, that is minus 3. The answer is 2 comma minus 3. See, you have to realize it's a problem on substitution, the simultaneous equation. So I will not be choosing any particular problem, but I want to give you some concept about this. So they will give you find a domain and range. These are the concepts normally asked. See, before we go for this, we should define what a function is. Let f from a to b, giving a definition. F is said to be a function from a to b if, this definition is very important, every element of A is associated with a unique element of B. I'm spending a little more time here because if this concept is clear, you can work any problem in functions. The two words are very important. Every element of A is important and unique element of B. Then only it's said to be a function. What is A called? A is called domain. B is called range. Sorry, B is called codomain. B is called codomain. What is the range? Subset of codomain. Containing the image elements of A. See, if I have a set A and if I have a set B and if I have got some elements like 1, 2, 3, 4 and if I have got set A, B, C, D, I associate like this, 1 goes to A, 2 also goes to A, 3 goes to B, 4 goes to C. Now when I need a definition, it is a function because every element of A is associated. There is an element of B which is not associated, but that will not The definition of function says that every element of A must be associated with a unique element of B. So we are not talking about the elements of B. So here the domain is going to be A, codomain is going to be B, range is going to be A, B, C. So remember, range subset of A contain images of the elements of A. Normally, I have seen in the question papers of CET, they give a problem. Some A is equal to 1, 2, 3 is given. B is equal to some x comma y, something like this is given. They give 4 answers. Which of the following is a function? To understand that, you should have a clear idea about every element of A must be associated. I will just give you a simple example. Thereby, you can always work any problem function. You take the set A as a students in a classroom. I am giving this example to make the function concept clear. Set B as the places to sit. Places to sit. Let us imagine there are 50 students and 50 places to sit. No problem, each one of them will get accommodation, place to sit. Supposing there are 48 places, then also it is possible to make 2 students or 3 students one place. Supposing there are 25 students and 40 seats, even then it is possible. What I am talking is, if you want a class to function, every student should get a place to sit. Supposing there are 25 students and only 5 seats, then also it is possible. Maybe we have a place of 5 people sitting in a bench. But if you find one student not being seated, it is not a function. This is a best example. Every student must have an accommodation, a place to sit. There can be vacant places in set B, but supposing I remove this, it is not a function. So if you can remember this analogy, students and places to sit, what will happen is you can always identify the given answers are functions or not. Here I will not be able to write those things because each one of them has got 4 or 5 choices, and each of the choices will have 4 or 5 ordered pairs. I am just giving an example. So what it would take is, the moment you notice that an element of A is not associated, or there is one element which is not associated, or there is an element which goes to 2 places. See, supposing I have a case like this: A, B, C, and 1, 2, 3. One A goes to 1 also, A goes to 2 also. Here, what we say is it is not a function because association is not unique. So uniqueness is very important. One object cannot have more than one image, but all objects can have only one image. That is called overlapping. So let us take a simple example of a domain. Find the domain of the function. You will always get some question based on domain and range. Domain of the function root of course f from R to R is given. Root of x square minus 7x plus 12. X square minus 7x plus 12. See, the most important thing in domain is the whatever function which is given, it must be defined. Whenever they give a root, it doesn't exist if the expression inside this is negative. So if you get a negative expression inside the root, the function doesn't exist. So what you want is x square minus 7x plus 12 should be greater than 0. The other possibility here I'm not going to discuss many functions, but I'm just giving an idea. Normally, whenever they ask a range, they will either give root or they will give a denominator 1 minus x, a function like this, f of x is equal to. These are the only two possibilities. Whenever root is given, the function doesn't exist, the expression inside the root is less equal to 0, no problem, less than 0. That means it should be positive. What about in this case? The denominator should not become 0. So when it will become 0? If x is equal to 1. So what do we say? It doesn't exist for r minus of 1, you should remove. So domain is going to be r minus of 1, you should not give it. Sometimes they give mod. That case you should take minus 1 and plus 1. I'll just brief this. Domain and range, they ask you, they will give either inside the root expression, inside the root, or they will give in denominator. For example, when this is given, you are going to solve this. When you solve this trinomial, 12 is what are the factors of 12? 4 entry, x square minus 4x minus 3x plus 12. So you can take x as a common factor, x minus 4, you can take 3 as a common factor. So x minus 4 into x minus. So what is that you have got to decide? You take a value, it is minus infinity to 3 union 4 to infinity. You should avoid anything less than that, because if you get a negative sign, this function will not exist. So you can just work some problems of domain and range so that any function given in the examination, check for this. And normally it will be given either inside the root expression or denominator. For example, one more problem they have given. Find the range of the function f of x equals x square minus 4x plus 5. There was a range here. So what you can do is, you can call this as y. Y is equal to x square minus 4x plus 5. Now, you cannot factorize this. So you have to play some games. What is that game? You have to write in such a way that it is possible to factorize. So you can write this as x square minus 4x plus 4. Or you can write this as y minus 1 is equal to x minus 2 whole square. So what is y or y is equal to x minus 2 whole square plus 1. So what is the possibility? If you want to find the most important thing is, here the problem is not domain, it is range. For domain, you are finding the value of y. For range, you have to find the value of x. So what will happen is, y minus 1 is x minus 2, or x minus 2 is equal to root of y minus 1, or x is equal to root of y minus 1 plus 2. So what should happen? Let me repeat this. The problem is of range, not domain. So what values x can take? Now, when we simplify this, we get x in root of y minus 1 plus 2. You know pretty well, this will not exist if y minus n is less than 0. So what should be the thing? Y should be greater than or equal to 1. So what is the range of this? Y greater than or equal to 1. So try to understand the concept. Whenever they ask a domain, just brief this. Find an expression for y. Whenever they ask the range, find an expression for x. For domain, you have to find an expression for y because limitations for y. For range, you have to find an expression for x. So, for example, in this problem, they have asked range, so we have find an expression for x, and this should not be negative, therefore y should be greater than 1. Plus 2 is okay. Similarly, if they ask the range domain for this function, then what we can do is we have to find a value of y. What's the value of y? Y is equal to x minus 2 whole square plus 1. Supposing they had asked domain for this function. So what is y is equal to x minus 2 whole square plus 1? This exists for every value of x. Therefore, the range is R itself. Here, it is greater than or equal to 1 because if you give any value less than 1, the expression inside the root will become imaginary. So these are the possible questions. I'll just summarize again what is. So the question will be find domain. I'll read this again. So instead of working many problems, I'll give you the concept so that you can work the problems on your own. Find range. What are the possibilities? They will either give a expression inside the denominator 4 minus x or 4 minus mod x, 5 minus mod x, or they will give you some expression like this, whatever it is. So here, why this is given is the function will not exist if denominator is 0. Therefore, x should not be equal to 4. Here, x should not be equal to either 5. We want this to be negative. So if x is greater than 6, so it is minus 6 if you take 5 minus mod x. So this is what will happen. So it is, this will become 0 if x is equal to 5. So it should not be equal to either minus 5 or plus 5 because modulus of minus 5 is also plus 5. So now if they ask the domain, find an expression for y. If they ask a range, find an expression for x. And you will see that either you'll have a denominator or you'll have a root. And if it is denominator, see the denominator is not equal to 0. If it is root, see that the expression inside the root should not be negative. I think that's all I just want to discuss today. So let me summarize what we have done today. We have discussed about sets. We have discussed about number of elements of a set. We have discussed about 2 to the power of mn. What is that number of subsets of a given set? And how many relations can be defined from that? And we also discussed about domain and range. And we have discussed about function. And when you see the previous year's papers, you will see at the most one question or 2 questions will come in this chapter. This chapter, set theory, relations and function, 1 or 2 questions. But we cannot take choices. We cannot leave the question. So what you can do is, if you know these concepts, the questions are mainly based on N of A and 2 to the power of m and the number of subset, domain and range. And one particular year, there was an interesting question. Let me work that and then close the class. In a survey, I'll work this problem and then close the class. In a survey of 1,000 people, it is found that 720 customers like A product. And 450 customers like B product. B product. What is the least number of people who like both the product? What is the least number of people who like both the product? I will work this problem by two methods. So it is given that n of A is 720. N of B is 450. You want n of A intersection B. There is a formula. N of A union B is equal to n of A plus n of B minus n of A intersection B. So n of A union B is totally 1000 people are there. N of A is 720. N of B is 450. This you have got to find out. Because negative sign is there, bring that this side. N of A intersection B is equal to, this is 1170 minus 1000, that is equal to 1. I repeat, this formula you need to remember. I just suggest you one more method for these types of problems using Venn diagram. Now, you have got people liking product A and people liking product B, and the entire has got 1000 people. See, you just add these two, you get 1170. But there are only 1000 people, so 170 should be here. Because there can be a question, how many people will like A only? Or how many people will like B only? So first you should add them and subtract 1000, you get 170. That is the people liking both A and B. But this is the people liking A. How many are there? 720. From that 720 you subtract 170. 550 people will like this. And from 450 you subtract 170. 280 people. So when you add this, 550 plus 170 plus 280. So what is that we notice here is using Venn diagrams, working these types of problems becomes very simple. So I'll just explain once again. 720 people like A product, 450 people like B product. When you add them, you are getting 1170. But there are only 170 people, 1000 people. Therefore, 170 people must be liking both the product. If the question is how many are liking both the product, 170. Sometimes they ask a question otherwise. How many people will like A only? That is 550. How many people will like B only? 280. So these types of questions can be there. And it's something, there are some questions regarding some people pass in the physics and some people pass in chemistry. How many people will both? So for all these things, I would rather suggest Venn diagram is the best method. So tomorrow, I will just start up with trigonometry. Inverse trigonometry. I have told you in my introductory class that these classes have its own limitations, but I will be concentrating more on the concepts so that these concepts will certainly help you to solve the problem. So tomorrow we'll discuss about trigonometry. I would rather just advise you to go through the formulas of trigonometry. Compound angles, multiple angles, submultiple angles, then allied angles. I'll just brief you the concepts and explain how the problems can be tackled. Thank you very much. We shall meet tomorrow.